When most people think about networks, they think about three-letter combinations like NBC or CBS or even PBS. But when we talk about networks, the more relevant three-letter combination is probably IBM. For IBM's new Token Ring computer network may finally put computer networking on the high-tech map. Today, we take a look at networks the computer kind on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by grants from AFIPS, the American Federation of Information Processing Societies, a non-profit federation of 11 national societies for computer professionals. AFIPS, Leadership and Service in Computer and Information Technology. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.
Welcome to the Computer Chronicles. I'm Stuart Chaffee, and this is Gary Kildall. Gary, all these wires and cables and connectors we have here are potentially part of a computer network system, or local area network, LAN as it's sometimes called. And I suppose one of the most important things to happen is the recent IBM announcement about its new Token Ring network system. Now, networks is one of those things that it seems computer guys have been talking about for years, but from a user's point of view, nothing really ever seems to happen. Is this IBM move now finally going to make things happen in networking?
Well, Stuart, local area networks let personal computers or office computers share huge data files. And when you're talking about office computers, then IBM set standards. There's no question about that. Now, if these standards can be set, I think there are going to be some real exciting possibilities in network-aware software that really uses those networks properly.
Gary, today we're going to go to New York to find out some more about the new IBM system. We'll meet one of the principal developers of Ethernet, and we'll shed as much light as we can on one of the more complicated computer topics. One of the issues in networking are the wires that are used to connect one computer to another, and we're going to begin by taking a look at a relatively simple system that uses existing telephone lines to connect computers.
As PC workstations become more common and their standalone functions more elaborate, they become increasingly attractive as alternatives to mainframe-based networks. But so far, they've had limited acceptance due to the usual incompatibility of operating systems and the expense of installing miles of coaxial cable. But the logic of a PC-to-PC network is powerful, and some new solutions have arrived. For businesses already equipped with a telephone PBX, a practical network can be installed over existing phone lines. One of the first of these is Northern Telecom's Meridian system, which works in conjunction with a PBX to handle both data and voice over standard twisted pair telephone wiring. Equipped with its logical counterpart, an integrated voice and data terminal, the network combines computer and communication functions, like an online directory and automatic dialing. Messages can be transmitted in text or voice mode, or a combination of both. Terminals tied into the network feature automatic logon to outside databases, protocol and code conversion. Two users can share multimedia information simultaneously. The star-shaped network allows shared use of printers and hard disks, and the internal bus operates at a respectable 40 megabits per second. Memory-enhanced telephones are nothing new, and any PC will store a directory of numbers. But this computer's digital voice has found a new, practical route to travel, along wires that you'd find in every office wall.
Joining us now in the studio is Bob Metcalfe. Bob is the founder and chairman of one of the leading networking companies, 3Com. And sitting next to Bob, Sherry Geddes, formerly of SciTech and now an analyst specializing in networks with Strategic Incorporated. Gary?
Bob, 2 years ago we had a show on LANs. At that point we were talking, I think, through modems and so forth to big computer systems. And I really didn't consider that, myself at least, a local area network. Would you say that we've really made some progress in the last 2 years, or LANs are successful, or just what's happened?
Well, I think LANs are going to be a long time coming, and they, for some of us, if they go back 10 or 15 years, I'd guess there's about 100,000 LANs with several 100,000 personal computers connected to them now, and to some of us that's a big number, and to others that's a small number.
Well, relative to the number of people that really need an LAN, I mean, well, the average person in the home really doesn't have to have a local area network, really, do they? I mean, so if we have 100,000 installed, I think that would be considered a success, wouldn't it?
A relative success. I think some of us think the potential is much bigger than that. In other words, we're looking at the arrival of PC LANs as sort of the next major generation of how computing is to be accomplished, and so to us, 100,000 LANs seems like a small number. There are 7 or 8 million PCs so far in business, and so I think the numbers could get quite a bit larger than they are.
Well, in the case of, let's take business as an example. The real advantage of a personal computer is it's sitting there on a desk, it's all by itself, but the disadvantage is that it doesn't have access to a big database, and it really isn't built for I/O processing. So is that where LAN really helps out in an office?
Absolutely. The standalone PC is sort of a transient in the development of computers. Useful up to a point, and as you say, one of the main reasons to have an LAN is to give that PC access to large amounts of data it can't have itself, or which is updated frequently by many, many other people.
Now, one of the things that's been mentioned is the token ring standard that IBM has proposed. This is just one of many different ways that these machines can communicate. Sherry, you've been working apparently with PBX systems.
Yes, I have PBX and local area networks.
Can you get high data rates, say through a PBX? PBX is basically a telephone system.
You can get high data rates on specialized PBXs called data PBXs. On the general purpose PBXs, the high-end ones, the integrated voice data PBXs, the rates are still relatively low. But the throughput's very good, and that's a critical distinction between throughput and data rate. Many users don't need a high data rate, they need a high throughput rate because lots of people need access essentially simultaneously.
Bob, now you've got a system here. As we mentioned, I think earlier, you were involved in the development of Ethernet, and you have a kind of derivative of that you call EtherMac, which happens to be connecting some Macintoshes here. Show us how this works, this existing network system.
Well, here's a Macintosh, which is now familiar to hundreds of thousands of people, but and you'll notice that there's this one diskette and its keyboard. Now, by putting this diskette in, what we're causing it to do is to go out over a network. It's connected to an Apple Talk network to a network server elsewhere in the building.
Okay, well, let's explain right now. In fact, we have the network server right over here elsewhere in our studio with Derek as if he were in another office, let's say, in the building operating another Macintosh, and that's the network server over there. Now, what's happening as you load this up then, Bob?
Well, because this is my diskette, and so it logs me into the network. That is, it identifies me to the network and hooks me up with my data which is not on this boot diskette, but which is elsewhere, in this case on that network server.
Yeah.
And then according to my normal practice, it's now identified me and connected me up to my data, and what you'll see here are what amount to virtual diskettes. Each of these icons represents a diskette that's on that network server down the hall.
Now, if you were to compare this, say, with the speed of data access from one of these from this floppy disk, from this little disk to the network, what's the comparison in the data rates?
It's a funny thing. You would think that going a greater distance, things would be slower. In fact, in this network, we get performances 2 or 3 times that you get off the diskette. That is, the network is faster than the disk in the network server. Is a Winchester disk, is quite fast.
Now, could you give us an example now? We've got Derek over there working in his office, and you want to find out what he's working on or share a particular file with him. Could we actually see you do that?
Well, here's I happen to know that Derek, this is Derek's diskette here called Data 2. So if I open it in the normal way that I would open a diskette, I now see a bunch of documents that Derek is probably currently looking at this very moment. And so if I were to go up here to let's say diag X and open it up, this is the same MacDraw document that Derek is now hopefully looking at on his Macintosh over there.
Now, this brings up the question about file protection, of course, and I assume that that's part of the system as well.
While I was connecting up to various volumes, if there was a password associated with the volume, I would have had to present it, as I did.
And how about simultaneous access to the same files, writing to the same files and things of that sort?
Well, most of the software that runs on PCs, and by most I mean 99% of it, is written to run on one PC. If you direct 2 PCs simultaneously at the same diskette and they both try to manipulate the data, some data damage can be encountered. And that's why you have to take special concerns in the designing of the network to be sure that people don't simultaneously manipulate the same data.
This is a sort of a traditional problem with taking single-user applications and bringing them into a multi-user environment.
Bob, your demonstration here happens to be with 2 Macs, but of course the system you're demonstrating could be with 2 IBM PCs or other computers, correct?
Yeah, in the case of this particular system, there could be hundreds of Macintoshes and hundreds of IBM PCs and compacts and so on.
Sherry, given the problem that Gary and Bob were talking about of standards, we have a system that's working right here. What's the big deal about the IBM token ring system? Is it just one of a new standard?
Well, it's a different approach. The type of system we have here is a collision-based system, and it provides very, very good access for users in an office-type environment. One of the key advantages of the token approach is that every device knows it is going to get the token at a predetermined time. This can be very important if you have, for instance, a factory-type situation where you know those devices have got to be polled every so many nanoseconds or microseconds, as the case may be. In an office environment, this is useful in a bisynchronous situation, an IBM Bisync. It is also useful if you have a very large population and you don't have any type of prioritization scheme to. Otherwise, you could literally have users who maybe never succeeded in getting on the network. I personally consider that's a very rare possibility. I think the significance of the token ring is for IBM customers and those shops that are primarily IBM equipment, because it will eventually interface into SNA and provide a very nice transition through.
Bob, on your Ethernet system here, we're just sharing files right now. You could be sharing peripherals, I assume, under this system also.
Yeah, and in fact, one of the strong advantages of this configuration is you could put a laser writer on the network server, and then all the PCs and all the Macs could send documents to the laser writer and share it.
What does this system cost? This is the example, what we're showing right here.
About $10,000 plus the cost of the PCs.
Okay.
Okay, Bob, Sherry, thank you very much. We've got to move on. We're going to next go to New York and take a look and find out a little bit more about IBM's new token ring system. Soon we'll see a demonstration here of a network that combines Macs and IBM PCs. First of all, we're going to meet another key player in the network story, someone who has another idea about all of this, Bill Godbout, the president of CompuPro. Wendy Woods has that report.
The difference between a multi-user system and a network is that a multi-user system is designed to be networked, unlike an office full of PCs. And one of the players in this market is Viacen, maker of CompuPro CPUs and terminals. Viacen's chairman says there are 2 advantages to going his route.
Speed of operation and the bottom line, the measure of all economic endeavors, is what does it cost, a cost-performance ratio that you look at. And actual bottom line cost is going to be quite a bit less for a lot more performance.
Godbout says multi-user systems are generally 20 to 50% less expensive than a network of PCs. CompuPro terminals use DataPoint's ArcNet, the networking architecture with the largest installed base in the world. This system can link up to 14 users and more if the CPUs are connected at central points called nodes. Viacen's own departments are interconnected in this way. Unfortunately, the biggest drawback to networking, whether we're talking about multi-user systems or a room full of PCs, is cabling. Cabling has to go throughout the building to every terminal hooked up to the network. There's not much that people in the industry can do about that, but one thing is certain. Even IBM is planning multi-user systems, systems which can be linked to a local area network of PCs. Meanwhile, how's business grown here in Hayward?
Several million%.
For the Computer Chronicles, I'm Wendy Woods.
The latest development in computer networks is IBM's new token ring network system for PCs. What is a token ring network, and will it finally set a standard for computer networking? We came here to IBM headquarters in New York to find out. We spoke with Richard Goldberg, Director of Marketing for IBM's division which handles computer communications. I asked him how the token ring network differs from IBM's existing PC net.
As you look at the PC network, again, for the small departments, small establishments, from a lower cost implementation, if that set of requirements is all the customer needs, PC network's an ideal solution. For the different set, for maybe an expanded set of requirements and capability, the token ring, which is a little bit more expensive is probably the better solution.
One nice feature of the token ring system is that it doesn't have to use IBM's expensive cabling system, but can work on regular phone lines. I asked Goldberg about the trade-offs.
When we looked at the telephone twisted pair and the cabling system, both perform at 4 megabits per second. But in order to achieve that performance, which is what we wanted to shoot for, you would put certain distance limitations, as an example, from the wall outlet to the wiring closet. In the case of twisted pair, it's 100 meters. In the case of the cabling system, it's 300 meters. The number of devices on a given ring, instead of the 260 devices, it's 72 devices for the twisted pair.
IBM is following its open architecture approach with the token ring network, and Goldberg says they learned the wisdom of that approach with the PC.
To be meaningful, it has to recognize the real world out there in terms of supporting a wide variety of device types that exist and that should exist in the future. So from a device standpoint, that's the value of being open. Second piece, the same thing, it has to support application development, it has to foster application development.
The next big step in getting full benefit from computer networking is to find software that is written to take advantage of it.
A lot of software has been grown up, has really been developed as single user kind of activity, either not distributed files, if you will, and it doesn't recognizing that distributed architecture. And what we see happening now is more and more software packages coming out with a true local area network implementation, which recognizing that files will be distributed, and in fact allows the databases to be distributed and managed that way.
Goldberg says the growth of computer networking fostered by the new token ring standard will have a major effect on the way we work.
We have an awful lot to learn about how to better manage ourselves and how to better operate once we start distributing files and distributing information and resources. And that's where really local area networks are. It's a resource sharing device, and it will change work habits.
Stuart, even if the token ring doesn't become the predominant standard, at least we know which way IBM is headed.
And that's a useful thing to know. Gary, I'd like to introduce now Nat Goldhaber is joining us. Nat is the president of Centram Systems West of Berkeley, California, and of course we've already met Sherry Geddes.
Nat, you have a different kind of a network system here. We saw a Mac connected up to a Mac. Here's a Mac now that's connected up to an IBM PC AT.
Okay, so let's make clear we've got the AT over there on the other side of our studio where our producer Holly Murray is, and you've got the Mac over here which is networked to the AT.
Right. It's important to point out that the TOPS product can network Macs and Macs, PCs and PCs, or heterogeneously both.
Okay.
This is a product which is a distributed file server environment. It is also inter-operating system, as you pointed out. That means that any device, any computer on the network, regardless of operating system or processor type, can act as a file server on the network or make its data available to other users. If we pull down our desk accessory, the TOPS desk accessory, it shows us the names of who's on the net along with an icon representing the kind of machine that it is. If we double-click on the icon of a specific machine, we can see that these data volumes have been made available or published for the network. And in fact, if we double-click on them, it allows us to, in the metaphor of the Macintosh, mount them. That means that those volumes are actually available to this Macintosh from the IBM PC just exactly as if they were inside this Macintosh. And in fact, if we take a look here, we can see that there's a mix of IBM files which appear as generic icons and actual Macintosh files in the same directory on the IBM. If we now close that, I can show you probably one of the most interesting demonstrations that we can.
Dan, let's stop for a moment.
Sure.
The programs that you're actually running on the Mac are 68K programs. That's the processor that's on this. And the programs running on the IBM AT are 286 programs.
That's right.
286. And so you're actually just sharing files. Not to say just sharing files, but you're sharing files in a very convenient way.
We're interchanging data freely between the different operating systems. Exactly correct. If I run this program called Microsoft Excel, a clever program by Microsoft which can both read and write to the Lotus 123 format, I can show you one of the advantages of this TOPS networking system. It is possible to open up a spreadsheet that it resides on the IBM AT that was created by Lotus 123 on the IBM T and use it on the Macintosh.
This could have been done by just transferring files, say, on a floppy disk or something, but this is a very convenient way of doing it.
That's right. This does it in real time.
Right.
So what are you doing now then?
I'm going to get a standard file box which shows me the names of the files that reside on the different volumes. Here is the IBM volume called Worksheets, and here is a WKS file, an unadulterated, legitimate Lotus file. Okay. If we click Open, it will now go to the IBM AT, get the data from that file, bring it to the Macintosh, and display it as if it were an Excel file.
Mm-hmm.
And
now,
here
let me ask you the same question that I asked Bob earlier, and that's how does this transfer rate compare to, say, the floppy disk that's on this?
It's slightly faster than the floppy disk speed to get it off of an IBM AT's hard disk, which, as you know, is very quick. Mm-hmm. So the speed is excellent on the network.
And also the cost of this is basically the node cost then, right?
Right.
Because you're not duplicating.
Exactly. It's a software-only product for the Macintosh. And Macintosh already has a networking system built into it. For the IBM, a card is required. The expected price for the Mac is $100. For the IBM AT, is $300 with card and software.
Let me ask you one question now that has to do with software, and this is the issue of now we're able to share files. What about the problem of licensing software? You now have, let's say, 1,000 nodes on this network. What does it mean to buy one version of the program?
We certainly don't recommend that anybody violate the licensing agreements that they have with the manufacturers.
But do the licensing agreements generally say anything about that?
Yeah, a lot of them say that it's for a single computer to be used locally by one single computer. I think, though, that all companies are now addressing the issue of so-called site licenses, which will allow multiple computers to use one copy of a program.
Sherry, we have about a half a minute left. From a user's point of view, should one sit back and wait till this network thing settles itself out before you buy something?
No, I don't think so, Stuart. The issue is so complex on several levels that if you wait, all you'll end up doing is feeling more confused than you do already. I strongly recommend that people get out there and get their feet wet. Get a small-scale network, hook up a few machines, try it out, and find out really what are the benefits of networking for your organization. Then you can make a much more informed decision. If you're thinking about networking the entire corporation, you have your much better idea of what will work for you and what changes it'll make in your organizational structure are.
Get into it now.
Get into it now.
Sherry, thank you very much. Where will all this network technology go? We're going to turn now to our commentator, George Morrow, for his thoughts.
Well, what's all this confusion about in the business of LANs? The culprits are as obvious as targets in a shooting gallery, and of course the biggest is IBM itself. They keep wanting to sell mainframes as file servers, and they're afraid that people that see wire won't pay as much for a mainframe if they don't see that wire. To keep the confusion at a maximum, they've embraced not one but 3 different standards, all incompatible. The latest one is the least efficient and the least reliable. But the problems with LANs might go a little farther than just marketing and the fear of not being able to keep selling mainframes. The boundary between the analog and digital world is a jagged one, filled with quagmires and landmines and the like. And LAN technology straddles that boundary. Now, ever since LANs have started, we've been sending in digital engineers to solve those problems, which are both analog and digital. And maybe they're just not up to it. That's my opinion. I'm George Morrow.
In the Random Access file this week, the intelligent office building, the intelligent home, and the intelligent factory were all in the news this week. First of all, several deals were announced to develop the so-called intelligent factory, where robots and computers run the whole plant. Hewlett-Packard said they had signed a deal with Bechtel to design and develop a completely automated electronics plant. Earlier, Ford Motor Company announced a deal with MeasureX to develop a computer-controlled system for running Ford's body and assembly plants. And General Motors said it is about to reveal its model for the factory of the future, using what it hopes will become the new standard for the intelligent factory, a standard GM is calling MAP, short for Manufacturing Automation Protocol. Meanwhile, the Real Estate Research Corporation says there are now nearly 200 smart office buildings around the world. Among the first were the Citicorp building in San Francisco and this new office development called Exchange Square in Hong Kong. Tenants in these buildings not only get centralized heat, air, and phone service, but centralized computer applications and electronic mail. However, the demand is still slow for smart buildings, with only a small percentage of tenants signing up to use the centralized computer systems. And the smart home is also coming on the market. Ryan Homes of Pittsburgh is the nation's first builder to be offering homes that come standard with computerized controls for all home electrical outlets and security systems, including the ability to program the home's electronics over the telephone. The most intelligent home of all is in Dallas right now. It's called Future Home, and it features 13 computers, 26 monitors, 14 telephone terminals, and a $500,000 price tag. Back on Earth, more than a dozen computer companies have already jumped on the IBM Token Ring bandwagon. AT&T, Data General, HP, NCR, Sperry, and Xerox all say they'll offer bridges to the IBM network, and networking companies like 3Com, Novell, Nestar, Proteon, Corvus, Bridge, and Ungerman Bass all have announced new Token Ring networks or links between their LANs and the IBM network. Time for this week's software review, and here's Paul Schindler.
What will they automate next? Rolodexes, calendars, index cards, they were all obvious candidates for oblivion in the digital revolution, but who would have thought they could improve on the globe? Well, the people who wrote Concept's computerized atlas. They have a clever sales method they call the Phoenix Plan. You can get the package for $5 and try it 3 times. Then it freezes up till you send them another $50. Clever, huh? Well, if you think the marketing method is clever, get a load of the program itself. After the animated opening, the cursor always starts at Springfield, Illinois. Because it does, that's why. We'll move it to Philadelphia, where a large Polish community might want to know how far it is to the shrine at Częstochowa, Poland. Over 4,100 miles. You want facts on the town and the country? Here they are. Switch to a map of Europe, and you can see the other side of this transaction. The normal view is from 12,000 miles out, but you can also move in for a close-up. The Concept's computerized atlas includes information on tens of thousands of locations. Armchair explorers will go crazy trying to exhaust the possibilities of this program. Alas, it is copy protected, which reduces its utility. Software Concepts, Stamford, Connecticut, will accept either your $5 or your $50. For the Computer Chronicles, I'm Paul Schindler.
Borland International says it's about to release new software called Turbo Lightning, a RAM resident program that provides an AI-based spelling checker, thesaurus, and encyclopedia. The price, $99 apiece. A court clerk in Sonoma County, California was arrested this week after he broke into the court's computer system and deleted court records relating to his recent arrest on drunk driving charges and canceling his scheduled court appearance. The courtroom hacker now faces 3 years in jail and a $10,000 fine. Finally, it may not matter whether you like new Coke or classic Coke, but some new Coke machines are now featuring built-in computerized games and speech synthesizers. The machines remind you to take your change, and they offer 2 video games. One, a kind of Space Invaders thing called Catch a Coke. Unfortunately, you don't get any free Cokes or money if you win. That would be classic or new gambling. That's it for this week's Chronicles. We'll see you next time.
The Computer Chronicles is made possible in part by grants from AFIPS, the American Federation of Information Processing Societies, a non-profit federation of 11 national societies for computer professionals. AFIPS, Leadership and Service in Computer and Information Technology. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.